Topic 4-3, Factoring Trinomials, Day 1. This can be referenced in our Holt textbook, Chapter 8, Section 3, on page 540, and also in Chapter 8, Section 4, page 548. Okay, we're going to review the block method, and some of you may not have seen this before, but what you're going to be looking for are sums and products. So you're always going to use this one to represent the very first term in our trinomial, and this box always represents the last term in the trinomial, and then the combination of like terms, adding these two together, give us the middle number. So in this case, will be a negative 3x when you combine a negative 6x and a positive 3x. So it's going to look like this as your product. I've actually written it twice. And then in the factored form, I've written it here, but let's show it on the outside of the box. To get x squared would require multiplying an x and an x. To get a negative 6x, you need a negative 6 times x to get this one. X times what is 3x? That would be a positive 3. And negative 6 times positive 3 will give us a negative 18, creating our factors, x plus 3 and x minus 6. Okay, in topic 4-2, we looked at ones like this, where you were to write the numbers that give the sum of a negative 5x and a product of negative 50x. If you recall, we used the calculator in the y equal mode to find the factors. If you want to think about, we don't have to use the negatives. We can come up with our integer rules in a minute. But 50 divided by x, second graph will get you to a table, and this lists the factors: 1 and 50, 2 and 25, 5 and 10, go down, 10 and 5, and then they repeat themselves. So we know that adding together with integers a 10x and a 5x to get the sum being a negative, if this one was negative and this one is positive, it would give me a sum. So multiplying a negative 10x times a positive 5x will give you a negative 50x. And then combining those two would give you a negative 5. So remembering that product you're dealing with multiplication, and sums you're dealing with really adding, but I like to use the word combine because here you actually subtract to get a negative 5x. Okay, let's look at example 3. If you were to factor this trinomial into its binomial state, we're going to use the box method. The first number goes in the first box, the last number goes in the last box, and I've written over here that we need the sums of our x's to equal 12 and multiplying them together. And you can think in lines of going this direction. I'll just draw it, well, I'll do it with the highlighter. If you think about this direction, these two multiplying together, this one and this one's going to get me to 32. This and this would get you to 32x squared. So these two squares multiplied together would give us a 32. So you're looking at figuring out which factors would be able to allow you to do that. Alright, so if you look at each of those, since this is just an x squared, you're not as limited to knowing what you're going to put here. But you're thinking of factors of 32 that are going to be an add-in of 12. So think a minute what those were. If you want to use your calculator, look at the factors of 32. But when you do so, you'll find that 8 and 4 multiplied together would get you that 32x squared. So this direction gets you 32x squared, and this direction gets you 32x squared. So this would be an x and an x. This is a positive 8, and this is a positive 4. So you've got, I should put the plus signs here. You've got x plus 4, x plus 8. The more of these we do, we get a little bit easier to figure out. But again, the sum is going to be this middle number added, and here, going this direction has to give us a 12y squared, and going this direction would give you a 12y squared. First term goes in the first box. Last term goes diagonally down here. This has to be a combined, when you combine it, we're going to get a negative 7. But when you multiply them together, it would need to be 12. So thinking about what would give you factors of 12, but a multiple, I'm sorry, a sum of a negative 7, but a multiple of 12. So think about that a minute. That would be a 3 and a 4. Now be careful. If I had put the, it kind of depends on where you decide to break this up. Let's say I put this here. If I say 2y and y, then I wouldn't put the 4 here, because if a 3 is here, there's nothing times 2 that would get me 3, but there is something times 2 that will give you 4. And that would be, remember we're dealing with negatives here. That was supposed to have been a negative 4. And this would be a negative. Both of them have to be negative in order to get multiplied together to get you a positive 12. But the sum of them on a number line, if you're at negative 4 and you combine it with the negative 3 more, you're down at negative 7 on a number line. The more we do this, this might come a little bit more clear to you, but again, you're looking at, and I'll draw it with a highlighter, if you multiply going this direction, you're going to get that 12y squared. Same thing as if you go this direction, you're going to get that 12y squared. This is just the box method of trying to figure where you're going to put each thing. And of course, something times y to get a negative 3y is negative 3. So you've created your binomials on the outside, your two factored binomials, y minus 2 and 2y minus 3. I think it'll help when we do a few more examples of these. So I'm trying to get it to where I want. Okay, let's look at number 5. You're taking the sums together. You want the middle term, which is 2s, multiplied together. This is how you come up with this multiplied together. I don't think I explained that on number 4. It's this first term and the last term, negative 48s squared. In other words, when you multiply diagonally this one and the last one, you're of course going to get negative 48s squared. So I want to get negative 48s squared going this direction, but I want it to make sure that I've got it as a sum together would give me 2. So if you think about it a minute, this would be negative 6 and a positive 8. Why these two? Because if I multiply this across, that's going to give me a negative 48. Multiplying these across gives you negative 48 s squares. This and this added together would end up with a sum of 2s. So now you just break it down to your binomials. What times what gives you s squared? What times s give me negative 6s? What times 8 is going to give, what times s is going to give me 8s? And then one of them has to be, let's see. Yeah, that's negative, the 8's positive, so a negative and a positive give you a negative 48. You've now created your factored form binomial s plus 8, s minus 6. Okay, I'm just going to walk through these. I think I'll do it quietly and let you just watch. Okay. Again, I'm going to keep emphasizing where we got that. This multiplied together gets you to the negative 18s. This multiplied together gets you to a negative 18x squared. Now these two are a little bit different in that you have to, last term would go in this box. It's just a little backwards, but it's still the same quadratic, just written in a backwards standard form. 6x squared goes here, 5 goes here. You multiply them together to get this. You multiply that together, you're going to get that. But the sum, you add these two numbers. Oh, I'm sorry. It's these two numbers that are going to give me that. But adding them, multiplying them together would give you 30. So let's go back to this one. Let's think about that. Where am I going to put which? If I put 10 times 7, then the only thing times 7 that I could put with a t is a 7. 7t. How am I going to get a negative 3 with a negative 10? Because when you combine these two together, that would be a negative 3. But if you multiply it this way, that gets you a negative 70t. And if you multiply this way, that gets you to a negative 70t. So if you want to write that, put it right out here. T squared, negative 70t squared. Okay, last one. This one's different because when there's a coefficient in front of the x squared, it gets a little bit trickier. So let's think of, if we put a 5 here and a 1 here, 5 times something that's going to give me 17 with a factor of 30. Let's see, 2 and 15. Notice why I put the 2 here. If I put the 2 here, there's nothing 5 could be multiplied by to get to. But there is something 5 could be multiplied by to get 15, and that would be a 3. And this is a little backwards. You got the x going here. And this one, let's see, that would be a 2x. And all of this is positive. There's a bunch of positives. So that your factored form is 1 plus 3x and 5 plus 2x. Oops, I forgot to write the factored form on this one. This was a negative t to get negative 10, and then this and this would have been just a t. Seems a little backwards to be putting this first, but you need to see that quadratics can be written this way too. 10, let's see, that one's 10 plus t. Yeah, that's right. And that concludes 4-3.